Hello everyone, myself Sri Raksha, student of SBCE from the Department of Computer Science and Engineering. In this video, I am going to discuss about the subject microcontroller. The topic I am going to discuss is about the Cpsr. Cpsr means current program status register. Let's see introduction to Cpsr. The Cpsr is a crucial component of ARM processor, and it is used to hold a wealth of information including conditional flags, interrupt mask, and a current processor mode. Let's see the structure and composition of the CPSR. The first one is about the 32-bit register. The CPSR is a 32-bit register that stores the current state of ARM processor. It contains various flags, interrupt mask, and mode bit that provides crucial information about the processor's operation. Next one is about the conditional flags. The CPSR holds 4 conditional flags, that is negative flag, zero, carry, and overflow flag, that indicates the result of last arithmetic or logical operation performed by the processor. Next one is about the interrupt mask. The Cpsr also provide two interrupt masks, that is IRQ mask and FIQ mask, which control the processor response to interrupt request. Next one is processor mode bits. The Cpsr's mode bit determines the current processor mode, which can be either privileged or non-privileged and can affect the available instructions and memory access permissions. Next one is about the conditional flags used in Cpsr. The first one is zero flag and it is denoted by Z. It indicates whether the result of last arithmetic or logical operation was zero. It helps the processor determining if the result met a certain criteria. Next one is about the carry flag and it is denoted by C. It is used to track whether a carry or a borrow occurred during the last arithmetic operation. This is crucial for multi-precision arithmetic operations. The next flag is negative flag and it is denoted by N. It shows if the result of the last arithmetic operation was negative. It helps the processor determining the sign of the result. The next one is overflow flag and it is denoted by V. The overflow flag if the last arithmetic operation can be cause overflow, meaning the result was too long to represent the distinction operation. Next one is about the interrupt mask in Cpsr. The first one is about interrupt handling. The current program status register in ARM processor contains two interrupt mask bits that controls the handling of interrupts. These interrupt bit, that is I bit, and fast interrupt bits, that is F bit. F bit and I bit. The F bit, when set normal, the interrupt mask will be disabled. When the I bit is set normal, the IRQ interrupt is disabled. By enabling and disabling the interrupt source, the processor can manage various interrupt derived tasks. Next one is about the interrupt priorities. FIQ, that is the fast interrupt, has more priority than an interrupt request, and an F bit takes precedence over the I bit. This allows the processor to respond quickly to certain criteria or time-sensitive events while still handling the less interrupt agents. Next one is about the interrupt handling flexibility. The interrupt mask bit in the Cpsr provides flexible control over the interrupt handling, allowing the processor to adapt to real-time application requirement and ensure the effectiveness of resource utilization. The next one is about the thumb state and its impact on Cpsr. The ARM processor architecture supports two instruction set modes, that is, the standard 32-bit ARM state and 16-bit thumb state. The thumb state allows for more efficient code density and can be beneficial to memory system. When the processor is in thumb state, the T bit in the CPSR is set, indicating that the current execution mode. This has a significant impact on the CPSR as certain instruction and state changes behave different in thumb state compared to ARM state. For example, the CPSR is updated differently when executing thumb state, affecting the conditional flags and interrupt mask. Next is about the privileged processor mode. The first one is about the supervisor mode. The supervisor mode is the most privileged processor mode in ARM architecture. In this mode, the processor has full access to all the system resources, including memory and peripherals. This mode is typically used by the operating system kernel for critical system tasks such as memory management and interrupt handling. Next one is about the abort mode. The abort mode is a privileged mode that is entered when the processor encounters an exception, such as memory access violation or a violation or undefined instruction. In this mode, the processor can take appropriate action to handle the exception. Next one is about undefined mode. The undefined mode is another privileged mode that is entered when the processor encounters an undefined instruction. This mode allows the processor to handle the exception and potentially enumerate the undefined instruction or take an appropriate actions. Next one is about the non-privileged processor mode. The first one is about the user mode. The user mode is a non-privileged processor mode in ARM architecture. In this mode, the processor has limited access to the system resources and it is designed for running regular user level application. The user mode has a lower level of privilege and cannot directly access or modify the system components. The next one is about the system mode. The system mode is a special non-privileged mode that provides a high level of access compared to user mode. Applications running in system mode can be perform more privileged operation but still have restrictions compared to full privileged mode. Next one is about the FIQ mode, that is fast interrupt request. It is also a non-privileged mode and used to handle high priority interrupts. It provides a fast interrupt response time compared to the standard interrupt mode. Application running in FIQ mode has a limited access to the system resource but can react quickly to certain events. The next topic is about the accessing and modifying the CPSR. The first one is about the reading the CPSR. The CPSR can be read by moving its contents to the general purpose register, allowing the processor to access and examine the various flags and mode bit it contains. This is typically done using a special ARM processor instruction such as move to register, from status, or from status register. Next one is about modifying the CPSR. Updating the CPSR is done by writing a new value to it. This can be accomplished by using a MSR, that is move to status register from register instructions, while allowing the program to set specific bits in the CPSR to change the processor state, such as updating the conditional flags or switching between the different processor mode. Next one is about the privileged access. Accessing and modifying the CPSR is privileged operations that can be performed in privileged processor mode, such as supervisor mode. This ensures that the processor state can only be changed by trusting an authorized code, preventing unauthorized modifications that could cause any effect or instability. The next is about the importance of CPSR in ARM processor architecture. The current program status register plays a crucial role in ARM processor architecture. It serves as a central hub for governing the processor states and behavior. The CPSR conditional flags, interrupt mask, and processor state settings are essential for efficient for execution, handling exceptions, and maintaining system integrity. By monitoring and manipulating the CPSR, the developer can optimize the performance of ARM processor-based system, ensuring that it is task switching, interrupt handling, and proper privilege management. The CPSR thumb state indicates for allowing the processor to, to efficiently switch between the 32-bit and 16-bit instruction set. Ultimately, the CPSR is a versatile and strategic placement within an ARM processor, making it fundamental component. Conclusion. In summary, the CPSR is a crucial component of ARM processor architecture, providing a window into a current state of the processor. From managing conditional flags interrupt masks to enable the thumb state and controlling privileged versus non-privileged mode. The CPSR is instrumental in efficient execution of ARM processor-based system. Thank you.